plus is a function which has taken two constants, two objects of type constant, okay, from the set of natural numbers. So, this is a function. Now, so here this is the functional term, plus is the functional term, 3 and 4 are constant terms, and 7 is also a constant term. So, 7 is the value, that is the object that is returned by this function, that is returned by this function. Okay. Now, let plus be a function that takes two arguments of type natural number and returns a natural number. Now, if that be my definition, well, then let us see plus 2 3, this one plus 2 3, that is a valid function. Plus 5 plus 7 3 is also a valid function, because plus 7 3 will return an object of type natural numbers, that is 10, and then therefore plus 5 and 10 both belonging to types natural numbers will add up and return a value of type W, that is 10, natural number 10, 15 sorry. Now, similarly plus 100, in that way I can go on writing this sort of statement. This is also a valid function, although there are a number of nested functions here. Here you see, based on my definition that I gave, that plus is a function that takes two arguments of type natural numbers and returns a natural number. Based on that definition, this is an invalid function, because minus 1 is not a natural number, and I have defined plus to be a function that takes two arguments of, both the arguments should be of type natural number and returns a natural number. Neither of these two are satisfied. Similarly, plus 1.2, 3.1, that is not a valid function based on the definition of plus, because 1.2 and 3.1 are not natural numbers, they are belonging from the real numbers. Similarly, we can have functions with variable arguments like plus x y, product prod x y z, any of these things we can have. It is not necessary, although in the examples we have shown, in the earlier example we have shown with constant, it can also have variables for that. Now, that is what is function. Probably some of you have learned that in the discrete structure course. You can consider this to be just a revision. Then what are predicates? Let us very easily understand that predicates are like functions, except that they can only return, the return type can be only true or false. These two constants can be returned. Other things are same as functions, but the return, a function can return any type of value, but here it is a little restricted, that a predicate will either be true or false. Okay. So, predicate is a function except that the return type is only true and false. Now, let us look at these examples. Greater than, GT stands for greater than. Greater than x y variables is true if x is greater than y. Now, these are variables. You see, in propositional logic we could not deal with variables. Here in predicate logic, in functions we can have variables, and predicates being nothing but functions, we can have variables in predicates as well, right, and that is giving us a lot more expressive power. So, greater than x y is true if x is greater than y. If x is instantiated with a value 5 and y is instantiated to the value 10, then greater than, this entire predicate will evaluate to false, because 5 is not greater than 10. So, here greater than is a predicate symbol that is taking two arguments of type natural numbers, but it is returning a value true or false. For greater than 3 4 is a valid predicate, but greater than 3 minus 4 is not a valid predicate. Why? Because greater than is a predicate that has been defined, suppose, to take two arguments of type natural number. 4 is not a natural number, minus 4 is not a natural number. Therefore, this one is not a valid predicate. Now, validity of the predicate has got no relationship with its being evaluated true or false. a valid predicate GTXY can sometimes evaluate to true, sometimes evaluate to false, depending on what values are being given to these variables x and y. Right. Now, let us see the different types of predicates. The simplest predicate is a predicate with no variable. If we have no variable, then I will get what we had done earlier, that is a proposition. So, Tommy is a dog is a proposition, we know that, and this thing is also a predicate. So, predicate is more general. So, predicates can capture everything that proposition can, but not the other way around. So, predicate with one variable is called a property. Dog x, that is x is a dog. If x is, if and this is true if and only if x is a dog. Mortal y is true if and only if y is mortal. Okay. So, a predicate with one variable is called a property. Now, how do we formulate predicates? Let P having arguments x, y, etc., and Q having arguments x, y, etc., are two predicates. Remember how we defined well formed formula or valid sentences in case of propositional logic. We have got exactly similar type of definition in the case of predicates also. So, in predicate logic, if P and Q are two predicates, then P or Q is a valid predicate, well formed formula. P and Q is a valid predicate, not P is a valid predicate, P implies Q is a valid predicate. Exactly these similar things we had in the case of propositional logic. Okay. So, let us have some more examples. If x is a man, then x is mortal. This is a statement that I want to make. So, I can write man x implies mortal x. This is a valid predicate, it is no longer a proposition because I have got variables here. Anybody, if anybody is a man, that means any man is mortal. So, in the clausal form it will be not man x or mortal x. If n is a natural number, then n is either even or odd. Just try to do it. If n is a